Hey everyone, welcome back to our channel where we break down IB Math AHL into quick and digestible lessons. And today we're covering geometry and trigonometry. Now this is an HL math video, so I won't be covering the absolute basics, things like SOHCAHTOA, basic angle rules, and simple trig ratios, because I'm assuming that you already know those. So instead we'll dive into the more advanced topics and concepts that you'll actually use in IB questions. That includes sine, cosine, and tangent rules, arcs and sectors, which is a little more difficult than the basics, and you might not know that yet. Pythagorean and double angle identities, and compound angle identities. So this is crucial for solving triangle problems, working with identities, and preparing for calculus later on. So yeah, let's get into it. So let's start with the sine rule and cosine rule, which help us solve non-right angle triangles. So the sine rule looks like this. A over sine A equals B over sine B. So in this case, A is the length of a side on a triangle. So let's draw a triangle. With sides A, B, C, and angle capital A, capital B, and capital C. So you can see that here A and capital A are opposite to each other, and same for the other letters. Actually, let me rewrite this sine rule. It goes all the way to C. It works for every side and angle. So here, the formula says that the side A over its angle on the opposite side is equal to the side B over the angle B. So let's say we had here 46 degrees, and this side was 7 centimeters, and then we had this side 8 centimeters, but we did not have this angle, and this is the angle we want to find. Using sine rule, we'll be able to find this angle theta, because 7 centimeters over sine 46, which is equal to 8 over sine theta. So if you rearrange this, you can see that theta equals sine inverse of 8 sine 46 degrees over 7. So sine rule doesn't get any harder than this. It's very simple. Once you get the hang of it, you just repeat questions over questions. It'll get memorized. You'll memorize it in your head, even though it is in the formula booklet. So now let's move on to the cosine rule, which is also used for non-right angle triangles. But this is perfect for finding a missing side when you have two sides and the included angle, or for finding an angle when all three sides are known. So the cosine rule is written as so: c squared equals a squared plus b squared minus 2ab times cos of c d angle. So next, let's talk about arcs and sectors, which appear in circle geometry and calculus. This is really not difficult. It might be a reminder for you if you already know about it. But you should know that the arc length, the length of an arc, is equal to S equals to R times theta. So the radius times the angle theta, and so this is the length of the sector of the arc, sorry. And then if you want to find the area of the sector drawn here, then the formula is also pretty simple. A equals 1/2 r squared theta, which is relatively similar to the area of a triangle, which is 1/2 times AB, which are two different sides, but here R is the same side because it's a circle, times sine C. So So sine of the angle theta that we can call theta as well. So these formulas are extremely important when working with circular motion, integration, and geometry problems in IB maths. But now we can talk about Pythagorean identities, which come from the unit circle and help deal with functions like, for example, sine 2x or cos 2x, which are relatively difficult if you don't know Pythagorean or double angle identities. But these are, these are in the formula booklet as well. I'm just going to go over them real quick. So the well-known Pythagorean identity states that cos squared of theta plus sine squared of theta equals 1. So this is a formula, an equation that you'll be using quite a lot in trigonometry questions. Usually in most IB past paper questions, you'll have to use Pythagorean or double angle identities. I guess the IB just likes to play with these because it's a lot of, it mixes algebra and trigonometry. So it does require a little bit of brain power, but it's still pretty easy. Double angle identities look pretty similar, and you'll often use it as you use Pythagorean identity. And the first one goes like this: sine 2 theta equals 2 times sine theta cos theta. And the second one is quite longer, but cos 2 theta equals cos squared theta minus sine squared theta, which is also equal to 2 cos squared theta minus 1, which is also equal to 1 minus 2 sine squared theta. So whenever you get a question where you see that these identities can be used, just make sure you spend a considerable amount of time on finding which one fits your question, and yeah, so you can find your answer, because most of the time it will be one of those or one of those. For example, you want to simplify a long expression, and then you can see that it would be easier to use 1 minus 2 sine squared theta instead of using 2 cos squared theta minus 1, for example. So finally, let's talk about compound angle identities. So these let us expand trigonometric expressions involving sums or differences of angles. So, for example, sine of a plus b, this can be developed and written as sine a cos b plus minus cos, well, actually plus minus here as well, plus minus cos a sine b. And for cos, it's pretty similar, but you have to make sure you do not mix them up, because here you'll see that cos a cos b, here it's not plus minus but minus plus. So if it's a plus b, it's going to be cos a cos b minus sine a sine b. And make sure you don't mix these parts up as well. It's very important. And we also have tan of a plus minus b. This one, it looks a little more difficult and less intuitive, but this is also in the formula booklet, so it stays relatively easy once you understand what the question you're faced with is about. So these identities are really useful for proving equations and simplifying expressions. And so that's a wrap on geometry and trigonometry. We covered sine, cosine rules, arcs and sectors, Pythagorean and double angle identities, and compound angle identities. And the next video, we'll move on to probabilities, which is one of the most important and challenging parts of the IB syllabus. And we'll break down differentiation, integration, and key techniques that you need to know. So yeah, if this helped, drop a like, subscribe, leave a comment if you have any questions, and see you in the next one.